23 says find the first term, the common difference, and give a recursive formula for the arithmetic sequence. Okay, so again I'm going to use the formula for the nth term. So I'm going to look at the 8th term is 30. Okay, so here's what I'm going to do. The 8th term, so the formula is A1 plus n minus 1. Okay, but here's the 8th term, so 8 minus 1 is 7. D is equal to, okay, 8th term is 30, so this is going to be 30. Okay, the second one tells me the 15th term, so again, using the same formula for the nth term, that's going to be A1 plus 15, so that would be 15 minus 1, this will be 14. 14 D is equal to 65. Okay, so again, just to make sure you can read this, this reads A1 plus 7D is equal to 30, A1 plus 14D is equal to 65, and basically to answer what they're asking me, I had to solve for A1 and for D. So one way I can do it here is multiply the first equation by -1, so solving by elimination. This will be negative A1 and A1 cancel, and negative 7D, now 14 is a 7. D equals, and then negative 30 and 65 is 35. So this 7D is equal to 35, so divide by 7, that would tell me D is equal to 5. D is equal to 5. Okay, so now let's plug in 5 here in the first one. That'll be 35, bring it over, negative 35. So I get A1 is equal to negative 5. So we know the first term to be negative 5. Right here. And we know the common difference to be 5. Okay. And once you know that, the recursive formula is it's always going to be a sub n minus 1 plus whatever the common difference is, and we found that to be 5. So it's going to be a sub n is equal to a sub n minus 1 plus 5. So the answer to this one is C. We'll clear this. Okay, go to 24 then. For 24, we want to find the sum of these terms. Okay, so you can see the pattern here. We're just adding 2. We're starting with 1, and we're adding the odd numbers up to 1069. Add 2 there, we get this. Add 2 there. So if you wanted to, one way to do it is to just list all of these. List all the missing numbers there from 1 to 1069, and then add them up with your calculator. Or you can figure out, since we go from an odd to an odd here, just add the 1069 and the 1 and divide by 2, and that gives me 535. So that tells me that there's actually 535 terms here. Okay, the 3 dots means they left out some terms. Okay, so a couple of ways to do this. One way is to use this formula for the sum. Okay, and this is an arithmetic sequence. This is an arithmetic sequence because we're adding the same number to the previous number to get the next one. So arithmetic sequence, and the sum of n terms is always going to be n divided by 2. And there's two formulas. I'm going to use this one that says in the parentheses I'll have the first term plus the a sub n term. Or in other words, if you know the first term and the last term, that's all you got to do. Okay, so this one then would read, in this case, like I said, I found n to be 535 here. 535. This is 535. And a1 is 1 here, okay? And the last term is 1069, so add the 1 in the 1069, divide by 2, and then multiply by 535. And that'll give you 286,225, or answer C. Okay, for 25, again, one way to do the problem. This is a summation, n equal 1 to 50 of 4n plus 2. So that means you would add 1 right there, and compute, that would give you 6, and then put a 2, okay, and that would give you 10, and you keep listing all of them until you get plug in 50, and you get 50 terms, add them up, and you could also use the previous formula that I just did. But in this case, because we're given a formula here, I can use the calculator. So again, I remind you about my other videos in the Tony Pereira channel, where I did a lot of problems like this. So I'm going to go to second, stat, and I'm accessing this menu right here. So I go over to 5, which is sum, and then I go again to second, stat, over to the middle menu, number 5, and this is sequence. So basically what I'm doing here is this function right here is going to list the terms of the sequence. That is all 50 terms, and this here sum is going to add them up for me. Okay, so to do that, all I have to do is put in this formula there. Okay, so it's 4x, I know it's n, but x is just a variable, so you can, for convenience, I'm using the x, plus 2. Okay, then a comma, and then tell the calculator the variable you're using, x, and then another comma, and then we just list the range. This would go from 1 to 50. Hit enter. I get 5,200. Okay, it's number 25. Okay. For the next one, it says determine whether the infinite geometric series converges or diverges. If it converges, find its sum. Okay. Well, again, I did a video on these types of problems before. So if the common ratio, in this case, and this for geometric sequences, we call them common ratio instead of common difference. Here we're multiplying by 1/3. 3 times 1/3 is 1. 1 times 1/3 is 1/3, and so on. So if the common ratio is between, that's r, is between -1 and 1, then it converges. So this one converges. Okay, what does it converge to? According to the formula, it'll converge to a1, or whatever the first term is, divided by 1 minus r. First term is 3 here, and the common ratio is 1/3. Okay, so I'm going to have 3 divided by 1 minus 1/3, which is 2/3. Okay, so 3 divided by 2/3 inverted multiply gives me 9/2. So the answer to that one is A. Okay, next one, again, is a geometric sequence. I'm multiplying, notice, by 1/4. 1/4 times 32 is 8. 8 times 1/4 is 2. 2 times 1/4 is 1/2. So 1/4 does fall between -1 and 1. So this one converges. So it's going to converge. It's going to converge to, so 32 divided by 1 minus 1/4. So that's going to be 1 minus 1/4 is 3/4. Okay, invert and multiply, and that'll give me 128 over 3, or answer B. Okay, running short of time, so again, I'm going to give you the answer to number 28. That's just using the formula for annuity. For 28, it should be C. It should be C. Okay, for 29, this is a combination problem. So this is again one where you can use the calculator. It's a combination of 242 things taken 3 at a time. So the way we do this in the calculator, easiest way to do it is to say this will be 242. Go to the math menu, over to probability. Number 3 is combination. Okay, and then put the 3. So this again, this reads combinations of 242 things taken 3 at a time. Hit enter. And I get 2,332,880. Okay, that's answer C. Okay, for 30 and 31, again, these are just taking these to the 5th power. So one of the things that you can use on these is the power tells you how many terms to expect. So this is a 5, so the answer should have one more than the power. So this should have 6 terms. Also, the first term should be this taken to that power. So the first term should be x to the 5th, and that is in all of them. And the last term should be 7 to the 5th. Okay, it should be 7 to the 5th. Okay, so obviously 7 is not 7 to the 5th. So you can rule out A and B. So the answer has to be B or C. By just basic computations, you should be able to figure out that the answer to that one will be C. Okay. On the next one, 2x plus 1 to the 5th. Again, you're looking for something that has 6 terms over here. You can rule B out because of the way it's written. The first term should be 2x to the 5th. Okay, which should be 32x to the 5th. And the last term should be 1 to the 5th, which would be 1. So this could be one of the answers. This could be one of the answers. This could be one of the answers. Okay. Simple computations for that one, you should be able to figure out that the one that works out best is 32. Okay. For the next 2 problems, is use the binomial theorem to find the indicated coefficient. So this one is kind of like these other ones here. You could go ahead and just multiply this out, put it in order, in descending order, and then get the answer that way. But there are formulas that you can use where you don't have to do that. Okay, so for the first one, says the coefficient, well, we want the coefficient of x and the expansion 5x plus 4 to the 3rd. Okay, so if you want the, here's the way it works. want the x sub j term, this is a j here, okay? If you want the x sub j term, you can get it by writing the terms of the expansion, okay, which in this case are 5x and 4. 5x and 4. That would correspond to the x here, and the 4 would correspond to the y. Okay, so if I do that, then this would be 3. Okay, so then this would be 5x to the first power, because you want the coefficient of x only. Okay, so this has to be x to the first, and this over here should be a 4, and by the formula it should be n minus j. So in this case j is 1, so that's going to be this should be 2. Okay, so this, if you look at the formula, this has to be the same as that, so this has to be a 2 here. Okay, now this is combinations right here. 3 select 2, you can use your calculator. This will be 3. And then this will be 4 to the second is 16 times 5. That's going to be 80. Okay, so this is 80. And then 3 times that, that'll give me 240. X. Okay, so if they ask you for the term is 240 x. They only want the coefficient, so the answer is 240. There you have it. Okay, let me clear this. Now the next one says you want the 6th term in the expansion. The 6th term in the expansion. Okay, so there's a formula for that also. So let me just say the j plus 1 term of an expansion is given by this formula. And j. And then the x and the y that I'm putting here are going to be the terms of that expansion, which in problem 33 are going to be the 4x and the 2y. Okay, so the j would go here then, and this would be n minus j. Okay, so this is saying then if you want a specific term of the sequence, then you're going to have each term of the binomial in this case. So this will be 4x. That plays the part of the x, and 2y. That plays the part of the y. So what the formula is saying is if you want the 6th term, the power on this 2nd term should be 1 less than that. Okay, which should be a 5. Okay, and then this, right? These always have to add up to the total power. So 11 minus 5. This has to be 6. Okay, and then the coefficient here is going to be obtained by the combination formula. So this should be 11, and this number here will be the same as that number there, and that will be 5. Okay, so then you're going to compute 11 combination 5 with your calculator. You're going to take 4 to the 6th power. You're going to take 2 to the 5th power, and then multiply those numbers out, and then x to the 6th, and of course y to the 5th. So if you do that, you're going to get answer B. 60,555,200. 264 x to the 6th, y to the 5th. Okay. Clear this. Okay, write down all the subsets of the given set. Okay. All the subsets, all the subsets should include the set itself, the empty set, and all the different combinations of one element taken from these to 2 elements, then 3 elements, and 4. And I remind you that if you have n elements, there should be 2 to the n subsets. So in this case, n is 4, so your answer should have 2 to the 4th subsets, which should be 16. Okay, just make sure that you have the set itself, and the empty set is always a subset of it. And you should be able to figure out that the answer to that one is C. C. Okay. For the next one, solve the problem if n of A is equal to, n of B is equal to, and then they give you information, they want you to find n of A intersect B. So the formula for this is n of A union B. Here we're talking about the cardinality of the set. This is going to equal to n of A plus n of B minus n of A intersect B. Okay, so again, that's the cardinality of the set. N of A union B is equal to n of A plus n of B minus n of A intersect B. So they give you n of A to be 36, so this is 36 here. N of B is 24, that's 24 right there. This is 54, this is 54. So solving for this quantity, bringing this over to this side and that to the other side, you should figure out that the answer to 35 is B, or 6. In the same way for 36, using the same formula, they give you n of A is equal to 60. They give you the intersection to be 20. They give you that n of A and n of B are the same. So what you can do here on this one, find n of A. So just put n of A right here and n of A right here. So this number, bring it over to the other side. So on this side, you're just going to have 2 times n of A. Whatever you get over here, divide by 2. And you'll get the answer to be 40. 36. Answer C. Okay. Use the information given in the figure. How many are in B or C? How many are in B or C? Okay. B or C includes everything in B together with everything in C. So basically all you can do is just add them up. 4 plus 2 plus 1 plus 18 plus 2 plus 28. That'll come out to 55. 4 plus 2 plus 1 plus 18 plus 28 and 2. 55. Answer to 37 is D. Okay. Find the value of the permutation P of 13 comma 6. Okay, so this would be kind of like the combinations, except it's permutation. So type in 13 on the home screen and go to math, over to permutations, or probability rather, and then number 2 is permutations. Type in a 6. So this reads number of permutations of 13 things taken 6 at a time. Hit enter. And that gives you answer C. Okay. For the next one, solve the problem, how many different license plates can be made using 3 letters followed by 4 digits selected from the digits 0 through 9. Okay, this one uses the multiplication principle. So 3 letters followed by 4 digits. Okay, so there's 3 letters and we can select from any of 26 letters. Now it says neither letters nor digits may be repeated. Okay, so once we select the first letter, we can only select from the remaining, which is 25. And then once we make that selection, we only have 24 to select from. See, if they said that the letters can be repeated, we'd have 26 times 26 times 26. There's 26 letters in the alphabet. Okay. 4 digits selected from the digits 0 through 9. So, okay, for the first one, we have any of 10 to be selected. And then we can repeat. So the next one, we have 9 choices, and then 8 choices, and then 7 choices. Multiplication principle simply tells us that we multiply these numbers out, and this will give me the number of ways that this can be true. So if you multiply that out, we're going to get answer D, 78,624,000. Number 40, in how many ways can 3 people each have different birth months? Okay, so again, 3 things to look at. We can select any one of the 12 months for the first one. Okay, but since they have to be different, the next one has to have, can be selected from 11, the remaining 11 months, and then the next one from the remaining 10 months. Multiply that out, and you get 1320. Okay, for number 40, it says from 8 names on a ballot, a committee of 5 will be selected to attend a political national convention. How many different committees are possible? Okay, this is 8 things, so you're going to take 5. So it's combinations, 8 things taken 5 at a time. So using your calculator again, on the main screen, 8, and then go to the math menu, select the function for combinations, then type in the 5, hit enter. You should get 56. Okay, again, briefly the next one again. An exam consists of 9 multiple choice questions and 6 essay questions. If the students must answer 7 of the multiple choice questions and 3 of the essay questions, in how many ways can the questions be chosen? So this is a problem that involves combinations, and it involves the multiplication principles. In other words, we want to figure out in how many ways do we have to select the multiple choice questions. Okay, so that means from the 9 multiple choice we have to select 7. So using your calculator, you figure out the number of combinations of 9 things taken 7 at a time. That's 36. How many ways can we select the essay questions? Okay, we're going to select 3. So 6 questions, select 3. So number of combinations of 6 taken 3 at a time. Use your calculator, you get 20. So you multiply the 36 and the 20, and you get 720. Okay, number 43. In a probability model, which of the following numbers could be the probability of an outcome? Okay, remember that for a probability value has to be a number between 0 and 1. You cannot have a number larger than 1. You cannot have a number less than 0. So you can have a probability of 1, which means the probability is certain, or the event, I should say, is certain to occur. And a probability of 0 means the event is not going to occur. Okay, so simply select the ones that fall between 0 and 1. Or they're 1 or 0. Okay, so it could be 0, 1, or anything in between. So for number 43, that would be D. 0, negative 0.2, 1 half 1. See, this one has a negative, so you can't have that one. This one doesn't have them all. This one has a negative. This one has a negative. Okay, or this one has a negative. And this one doesn't have them all. So the answer is D. Okay. Number 44. Determine whether the following is a probability model. Okay, it's going to be a probability model, obviously, if the probabilities fall between 0 and 1, including 0 and 1. Okay, these are okay. But for it to be a probability model, the total probability has to be 1. So if you add these up, the total here is going to be larger than 1. So for number 44, the answer is no. 45. A bag contains 7 red marbles, 3 blue marbles, and 2 green marbles. If one marble is selected at random, determine the probability that it is blue. Okay, well, there's 3 blue ones out of a total of 12. So the probability then is 3 over 12, which is 1/4. So that's answer A. A 6-sided die for 46. A 6-sided die is rolled. What is the probability of rolling a number less than 3? A number less than 3 would be either 1 or 2. So that's 2 out of 6, which give me a value of 1/3. Answer A. 47. A bag contains 15 balls numbered 1 through 15. What is the probability of selecting a ball that has an even number when one ball is drawn from the bag? Okay, so the total is 15, so that's going to be the number in the denominator. And then you simply count the ones that are even from 1 through 15. 2, 4, 6, 8, 10, 12, 14. So that gives me a total of 7. So that's 7 over 15, which is D. 48. Given that P of A is equal to 0.26, P of B is 0.35, find P of A union B. Okay, so for this one, this would be kind of a formula very similar to the one we had for cardinality, except this is probability. This one states the probability of A or B, or the probability of A union B, is equal to the probability of A plus the probability of B minus the probability of the intersection. That is, they both occur at the same time. Okay, so this one's very similar to the formula for cardinality. We're given P of A to be 0.26. We're given P of B to be 0.35. We want to find P of A union B. We're not given the value of P of A intersect B, but we're told that A and B are mutually exclusive. That simply means that they cannot occur at the same time. So basically that's telling me that this probability is 0. So adding the P of A and the P of B gives us 0.61, which is answer C. The next one, the table below shows the results of a consumer survey of annual incomes in 100 households. What is the probability that a household has an annual income of $25,000 or more? Okay, $25,000 or more. That's this category right here. So basically then we take the 27 and the 28 and the 20 and we add them up and we get 75. And of course the total is 100, so convert that to a probability. That's 75 over 100 or 0.75. So the probability is 0.75 or C. Okay. Number 50. A spinner has regions numbered 1 through 18. What is the probability that the spinner will stop on an even number or a multiple of 3? Okay. So again, even number or a multiple of 3. So you have to list all the events that correspond to that. So the even numbers from 1 to 18 would be 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. The multiples of 3 obviously would be 3. Okay. So I count that also. The next one would be 6. But 6 is also even, so I already counted that one, so I don't want to count it again. And then the next one would be 9. That's a multiple of 3. That one I haven't counted yet because it's not even, so that's 1. And the next one would be 12. That's a multiple of 3. But I've already counted that one because that's even. And so the next one would be 15. So adding those 3, 9, and 15 to the total of the even numbers, we give 12. So it's 12 out of 18, or 2/3. So the answer to that one is B. Okay, this concludes the video. I did go a little bit fast, so please feel free to stop the video and pause it and go back. And if you have any questions, let me know. I remind you again that check out the Tony Pereira, that's P-E-R-E-I-D-A channel. I have some other videos where I covered a lot of these types of problems using the TI-83. So that'll be it for today. Hope to see you later. And if this helps, please subscribe. And we'll check you in the next video.